Hello, class. Good day. This is your last chapter coverage for the midterms, and in this chapter 12, we're going to talk about oceans and fisheries. There are four subtopics in your module. We are going to discuss very briefly what are the patterns of circulation in the ocean. We will also discuss the major ocean life zones, and we will also discuss the human impacts on the ocean. First of all, let's take a look at this wonderful world below us. And I want us to imagine that there is rich marine life down there. The problem is the food chain. Man, being the apex predator, would always try to do something to exploit the natural resources. It has been estimated that much of marine life, including this amazing sea turtle, is endangered. The United Nations estimated around 60%, others would say 80% of fish stocks have been depleted or due to overfishing. So that is the problem when it comes to marine life. And unless we can do something to commit to the preservation and sustainability of our ocean and fisheries, it is going to be a serious matter like climate change. And it is said by the year 2050, if nothing is done, there will be no more fish in this great, amazing water world. So let's proceed with the subtopics. First, we'll be talking about the patterns of circulation in the ocean. Are there underwater currents or flows or patterns of circulation under the ocean that affects marine life? Is there an order to things? Second, we will also be talking about the major ocean life zones. How deep is the abyss? And what's the difference between photic and aphotic creatures? And lastly, we'll talk about the human impacts on the ocean. Other than overfishing, what are the other dangerous activities that man does, and what can be done to stop it so we can still see these amazing creatures under the ocean? So let's begin. Here are a few facts about the ocean. It covers around 3/4 of the Earth's surface, and in terms of percentage, that would be about 71%. It is also home to over uh, this number. Um, well, scientists would say there are more than this number, 226,000 marine species, because much of the endemic species and much of those that have, uh, especially those that are way deep into the deeper regions, have been identified, and some of them have been extinct before they were even identified. And it is estimated that the average depth of the ocean would be around 3,795 meters up to a height of 840 meters. And 90% of the living space on the planet is actually made up of the oceans. In other words, given this vastness of the deep, less than 10% have been only discovered by humans. I think there's so much more about the ocean, the water world, that we have not yet fully discovered. Matter of fact, 50 to 80% of all life on Earth is found in the ocean. Of course, that is uh, probably something logical given its vastness. So when we talk about this big, dark underworld, how do we imagine how things flow in the water? Is there an underwater current system that exists? And the answer is yes. And we will be looking at these patterns and is illustrated here in the map on our module. And there is this thing called gyres. That's how it's called. And these are large circular ocean current systems. If you notice in the map below, there are more than one systems. They are all over the globe, simply because this is when the water interact with the landmass it actually creates. As the water tries to have this momentarily constant impact on the land, it creates a life of its own. It creates a current of its own system. And these gyres are huge and they are powerful. You might say they are connected to our idea of this underwater current. So let's take a look at some of the illustration here. We have the blue coded and the red coded current. So these are the underwater current. And when you try to look into the different bodies of water here, like in the Indian Ocean, you would probably see here that the currents can be made in terms of the temperature of the water. So the red ones would be referring to the warm current, and there is also the cold current as illustrated by the blue arrows. So you can basically try to notice that down here in the Antarctica, you would have the cold current flow running across the region, and somewhere in between this land masses, there would be the warm current entrapped and also running sporadically in between these land masses. So that is gyres. In order to understand what gyres are and how we can imagine this huge underwater current that would be affecting us and many other life forms, we will take a look at this video and let's watch. Let's see.
So a gyre is a natural phenomenon. A gyre is simply a rotating current system that's comprised of the Earth's rotation coupled with currents and prevailing winds. So it's essentially like a massive whirlpool, a vortex in the oceans. Say a piece of floating plastic from California in the North Pacific Gyre can take 10 years to make the rotation from California to Japan and all the way back.
So what we have found is that these plastic particles are not just in the North Pacific Gyre, they're in all 5 subtropical gyres, and all these gyres have several garbage patches in them, 8 garbage patches total in the 5 gyres.
So that was our inspiration to start the 5 Gyres Institute, to look at this plastic pollution issue on a global scale and try and show the world this is an international problem. These plastics are coming from every continent in the world, and solutions have to be on the international level. When I first heard this talk in 2001 from Captain Moore, I heard description of an island of garbage that people were calling the Great Pacific Garbage Patch. In the media, it was described as a Texas-sized island.
It's really hard to quantify how much plastic is floating in the world's oceans. These garbage patches that exist in the gyres, they're elusive, they change shape, they move around. You may trawl for 10 hours straight, you'll get a handful of plastic. You put it back in, 10 hours more, and there's nothing.
So it's essentially like a plastic soup of all of this disposable waste that we create on land masses, from California to Asia, Canada, Mexico, enters this North Pacific Gyre and gets swept up into this accumulation zone.
Islands in the gyres we're discovering are the natural nets for trash at sea. It's impractical to try and scoop out trash out of the ocean. What we can do is wait for it to wash ashore. So to clean a gyre, clean your beach, clean your watershed, clean your street. As close as you can get to the source is a better way we can solve the problem of plastics in the ocean.
So based on the discussion of the experts, we can now therefore imagine the gyre or the ocean to be like a big washing machine on spinning mode. And that explains why when something is a flow to the ocean. It doesn't really flow straight from point A to point B. It actually goes to in a circle. Imagine the plastic trying to travel from one place into another and going back into the same spot over a span of 10 years. So the plastic problem has been discussed. It's a powerful tool in trying to illustrate that when we talk of the ocean, we have to be very careful on what you put in it, because it is like a giant vortex. So if you try to put plastic, it generates like a plastic soup. So if we have like a plastic soupy kind of ocean, that would be very, very problematic. And another concept that is related to these underwater current systems is the Coriolis effect. It has been explained a while back that as the Earth rotates and there's underwater current ocean, the gyres are affected by the rotation of the Earth and also the current. And we also have the phenomenon here wherein the rotation of the Earth and in combination with the ocean's currents will actually create some kind of a Coriolis effect. Let's take another video in order for us to clearly imagine and picture what the Coriolis effect looks like in relation to gyres in the ocean water currents.
In these cells, and how the rotation of the Earth influences these winds to give us jet streams and prevailing wind patterns. As well as being split into 3 cells, the global circulation pattern is at an angle due to the Earth's rotation. The spin of the Earth induces an apparent motion to the right in the northern hemisphere and to the left in the southern hemisphere. This is the Coriolis effect. The key to the Coriolis effect lies in the fact that the Earth's surface rotates faster at the equator than at the poles. This is because the Earth is wider at the equator, so has further to travel in one day. The result of this means that as air moves away from the equator, it doesn't move in a straight line relative to the Earth's surface. Instead, it appears to an observer on the ground to move in a slightly curved direction. But there is no physical force causing this deflection. As the atmosphere rotates with the Earth, it is just due to the air flowing from a region that is moving faster to a region that is moving more slowly. To explain this further, imagine an air parcel as a ball. The ball is thrown from the equator towards a point near the North Pole. Even though it moves in a straight line, the ball will appear to an observer on the ground to curve away and land to the right of its target, as the point near the North Pole is moving more slowly and is not caught up. If the ball is now thrown from the North Pole towards a point near the equator, it will again appear to a surface observer to land to the right of its target. But this time it's because the Earth's surface at the equator is moving faster and is moved ahead of the ball. This effect only happens on objects that are in motion. This deflection is a major factor in explaining why winds blow anti-clockwise around low pressure and clockwise around high pressure in the northern hemisphere and vice versa in the southern hemisphere. So when flowing towards the North Pole, air is deflected towards the east, and when travelling southwards back towards the equator, it is deflected westwards. The same overall result occurs in the southern hemisphere. How does this lead to eastwards flowing jet streams and prevailing winds? As air moves away from the equator at the top of the Hadley cells toward higher latitudes, it starts to be deflected by the Coriolis force. Just as a skater spins faster by bringing their arms and legs closer to their bodies, air moving away from the equator speeds up as it gets closer to the Earth's spin axis. This process is known as the conservation of angular momentum. The magnitude of the Coriolis force increases towards the poles. So by the time the air reaches 30 to 40 degrees north or south, it is moving in an eastward direction. This subtropical jet stream occurs high in the atmosphere between 12 to 15 kilometers. It is associated with some of the strongest winds on Earth, reaching over 280 miles per hour at times. As this jet sits between the descending branches of the Hadley and Ferrel cells, there is little associated weather. The polar front jet forms in a different way. This jet sits between the rising branches of the polar and Ferrel cells. It marks the boundary between cold polar air and warm tropical air, known as the polar front. The polar front jet occurs at a height of 11 to 13 kilometers and is primarily the result of the temperature contrast across the polar front. The stronger the temperature contrast across the front, the stronger the jet. So it follows that the polar front jet is stronger in the winter than the summer. Waves or ripples along the jet stream can cause Atlantic depressions to deepen explosively as they are steered towards the UK. Winds at the surface are also subject to deflection from the Coriolis force. The surface flow of the Hadley cells form the persistent trade winds. As air flows towards the equator, it is deflected towards the west in both hemispheres, forming the northeast trade winds in the northern hemisphere and the southeast trade winds in the southern hemisphere. The persistence of these winds allowed sailing ships to cross the Atlantic and opened up trade routes between Europe and America, giving them their name. The surface wind in the Ferrel cells would flow from a southerly direction in the northern hemisphere, but the Coriolis effect causes this wind to be deflected to the right, leading to the prevailing westerly and southwesterly winds often experienced over the UK. This setup is not unique to our planet. Jupiter also has circulation cells similar to those on Earth. A day on Jupiter lasts for about 9.5 hours, so it is rotating much more quickly than the Earth. The great size and fast rotation of this planet makes the Coriolis effect very strong. This splits the Jovian atmosphere into many circulation cells in each hemisphere, producing numerous alternating bands of rising and falling air and giving Jupiter a distinctly striped appearance.
So what can we learn from that amazing video? We have learned that the Earth is spinning on its axis and it creates angular momentum, and with that it creates this Coriolis effect. And you know that rotation on the central region is much faster and stronger than on the upper and lower north and south pole. And we have also learned that basically this is the reason why when we have weather disturbances, it doesn't actually travel in straight direction. And that is why when we have weather disturbances like LPA, it may be deflected. Okay, so hence we pray, okay, sana pupunta sa Japan or sana pupunta dito. And that is why this Coriolis effect actually affects weather changes, the dynamics not only in air but also in water, okay, climate. Eventually, in the long term, although there is a stable pattern as we have seen in the North Pole, the solar jets, and it has been explained much later on that this is basically something that is not unique to Earth. Jupiter also has this and spins much stronger. But so the takeaway in that video is the idea that the ocean, in connection with the Coriolis effect, the rotation of the Earth, gravity at the atmosphere, is a very dynamic world. It's a very turbulent world. And when we think of the species living there and man trying to do activities that are high impact when it comes to this ongoing systems, long-term impact, climate change, magkakaroon nga talaga yan ng effect. So we're just trying to say that in as much as the water world, the oceans have a more dynamic and more sensitive ecosystem, and it has a life of its own. And as we try to go much further, and other things that can affect this life force, this dynamism, is also the density of the seawater and the temperature. There's so much more going on there. And um, therefore, this, oh, another thing that comes to mind would be that of what is created out of this dynamism, out of this underwater current. We try to come up with like a big, huge loop that would connect all this underwater current. In a way, meron bang isang big flow? Meron po. Yan po yung ocean conveyor belt. Okay? So if you try to put that into like one big loop, and it says here, this represents the global circulation of shallow and deep current. The ocean conveyor belt does affect the regional and global climate. If we were to represent that in by this map, this is how it would look like. So the underwater current system that is made up when you try to connect the warm waters and cold waters, and of course the warm water would come from the shallow waters and the cold would come from the deep waters, those that are not already being reached by the light. You try to come up with pattern, you would have this great ocean conveyor belt. And happens, this occurs constantly, and it actually tries to find its way amidst the landmass. You can imagine during the time when Pangaea is still Pangaea, this might probably look different. And if we can imagine with this ongoing cataclysms, okay, plate tectonics, earthquakes, this in the long term is definitely evolving. Pag mawala na ang Pilipinas, mawala na yung mga ibang bansa dyan, lumubog na, baka mag-iiba na rin yung shape nito. No? It's just like, probably some of you would be looking at it like a big rubber band. Okay, and it's probably sensible comparison. So this conveyor belt will make us understand that eventually the reaction of the cold and warm water and which one is stronger and what time, which region affects what, will eventually create another phenomenon which we are familiar with. These are the La Nina and the El Nino. So let's try to dissect them individually. Let's start off with the El Nino. El Nino is the warm phase of the Enzo here. And it was stated here that El Nino came from Spanish term, and it meant the little boy because it was observed by the seafarers in South America around the 1600s that around December there would be the unusual warm water in the Pacific Ocean. And so that's the analogy and the birth of and the coinage of the name. Whereas when we talk of the La Nina, it is of course the opposite of El Nino. It is just like creating contrast. If you have the hot water and then you have the cold water, because these are opposites. So the La Nina is otherwise known as the cold phase of Enzo, and the opposite of El Nino, which is the warm phase of the Enzo. And we will be looking at another video how these two are actually related. And we will be trying to answer some of your observations that if this year is La Nino, then probably next year is El Nino, then probably next year is La Nina. Di ba parang may ganon? Next year daw, El Nino kasi ngayon daw. Okay. We will be looking at another video to try to explain this and how these two are actually related and how they can be seen as a gauge of global warming or climate change or the things that are happening around our ecosystem, and we will try to see if these are indeed good or bad.
The world, from America to Antarctica to Australia. From the Spanish for little boy, it's known as El Niño. Its other cycle is La Niña, or little girl, with the in-between phase called neutral. The swing between these phases forms the El Niño Southern Oscillation, or ENSO, one of the most important climate drivers in the world. ENSO is a major influence on Australia's climate. El Niño and La Niña events can cause natural extreme events such as bushfires, drought, heat waves, floods, and cyclones. As the Earth spins, trade winds stream across the planet, driving warm surface seawaters across the vast Pacific Ocean. These sea surface temperatures create predictable patterns of circulation in the atmosphere and ocean. Climate scientists gather data from ships, weather stations, ocean robots, and satellites to measure the swing between the three phases of ENSO: neutral, El Niño, and La Niña. A La Niña event tends to bring above-average rainfall to eastern Australia. During an El Niño event, there is a greater chance of drought and bushfires. Each El Niño and La Niña event lasts about 6 to 12 months. It takes, on average, 4 years to cycle from El Niño to La Niña and back again. But no two El Niños are the same. The strong 1997-98 El Niño impacted every continent in the world, causing widespread devastation worldwide. This story begins in the eastern Pacific. Here, trade winds blowing from east to west push warm surface waters across the planet, piling up warm water in the western Pacific. Above the ocean, warm air rises, driving atmospheric circulation patterns known as Walker circulation. Cold, nutrient-rich waters upwell in the coastal ocean, replacing the warm water pushed away by the trade winds. Like an athlete pumping iron, the La Niña is the muscled-up version of the neutral phase. Trade winds become strong, and more warm water builds up in the West Pacific. The excess of warm water increases evaporation and precipitation, causing floods and forming tropical cyclones off the northeastern Australian coast. This warm water escapes through the gap between Indonesia and Australia to supercharge the Leeuwin Current, a 5,500 kilometre long flow of warm waters along the Western Australian coast. But, like an athlete, the winds can't keep pumping at this speed forever. Sometimes the winds weaken and warm water sloshes back across the ocean to the East Pacific. The Walker circulation breaks down, weakening or even reversing the trade winds. Warming of the Eastern Pacific accelerates, setting off a feedback loop that keeps most of the rain-producing evaporation in the middle of the Pacific. Due to the movement to the east of warm surface waters, northern and eastern Australia experience clearer skies, higher temperatures, heat waves, and increased risk of drought. Off the coast, fewer tropical cyclones form, as tropical activity is concentrated further east. Off the coast of South America, upwelling of cold waters is suppressed, and warmer surface waters result in higher than normal rainfalls and sometimes flooding and hurricanes. In Western Australia, the Leeuwin Current tends to be weaker and cooler during El Niño events. During the 2010-2011 La Niña, marine waters that were up to 5 degrees warmer than usual caused mass deaths of marine life, as well as coral bleaching along the Western Australian coast. However, warmer La Niña waters are generally beneficial for species such as the western rock lobster, whose larvae ride the Leeuwin Current southwards. In La Niña years, more lobster larvae settle to the ocean floor, meaning greater numbers are available to fisheries. 2015 is the first strong El Niño in 18 years. In the future, understanding when, how, and why these events happen will help us to manage the risks that they bring.
So from that amazing video, we have confirmed our suspicion that they do come in cycle. But not every El Nino or La Nina is the same. And so It has been explained in a very technical detail that uh, there is a pattern, there is an oscillation, and this warm water, too much of it is not good. Although much of the video explained the Australian setting, you can just imagine that the cycle on a greater scale, including us, the smaller island nations, still affected because this actually occurs on a regional large scale. So the video ended with a challenge that there is a cycle, there is a pattern. And if you're talking in terms of climate change, if we try to understand this pattern, if we try to be more mindful of our activity in a way that how we impact this oscillation of the La Nina and El Nina, we can actually prevent future catastrophes because we have seen the effects: drought, flooding, coral bleaching. That would mean starvation. No fishes for our farms except for lobsters, but we cannot survive on lobsters alone. So, with that, we hope and pray that our world leaders and we as individuals will become more enlightened, will try to do our part in our own small way, at least, even on the awareness level that these things are happening, whether we care or not. So, moving on with the video with this module, we will now go to another subtopic here, which is the major ocean life zones. I'm trying to pass through the activities. We're not going to do those activities. We go ahead with the understanding that if you try to look into this illustration, ito yung Pampang. This is the beach as you know it. This is the intersection of the land mass and the water. This is the ocean and the fisheries, and this is land. So each regions are labeled with reference to the land mass, and the shallowest part to the deepest part. We first start with the landmass, the littoral zones, and dito yung ating beach. Okay, so littoral pala siya. And then as you try to go deeper, then it's called the sublittoral, to the bathyal and the abyssal. So that's hence the word abyss. But there's even what's deeper than the abyss. Meron pa po itong hadal or hadal. And in some areas, this could reach as deep as 10,000 meters. Of course, we know that the deepest of the deep lies within our backyard. It is a trench, the Marianas Trench. And if you go into measuring the different parts, the layers, the major life zones in the water, we would be looking at these terminologies here. Okay, the top part where you go, where you do your island hopping, where the waves are, you're surfing, is the pelagic region. These are the oceanic and epipelagic region. And down below, where there are no waves, probably ito yung mga submarines, the mesopelagic. And down below, malapit na sila kaya Titanic, tsaka yung mga ruins of the dead, we have the bathypelagic. And the deepest part, the abyss, would be the ocean floor as we call it. But the technical term, they call it the abyssal pelagic. Now, in relation to the question, these are the major areas, not only in terms of this geographic structure, but the life zones. We're looking at, is there life? What kind of lives exist into these different regions? First, we take a look in terms of the depth, that it depends on how much light actually, the amount of light that enters into this region, along with the water temperature and the existence of food, planktons, algae, fish. This would all try to determine the existence of species in every region. Logically, as you read through this module, you will know that, okay, the littoral zone here is where the freshwater and saltwater meet, and what kinds of life is supported in there. Of course, other than the freshwater biome, the littoral zone is also an area with an abundant and varied species because you have freshwater fishes and saltwater fishes, flora and fauna, and there's abundant of light, and there's prolific photosynthetic activity, and definitely it hosts wide variety of marine life and aquatic plant life. Going down this zone, we have these subzones known as the sublittoral and the supralittoral. As you go deeper, you would have what we call the spray zone. And um, you would also have the zones wherein the intertidal zones located between the high and low tides. The sublittoral zone is always underwater and is below the low tide line. So you know that the water has a high tide and the low tide zone. And these subzones of the littoral zone actually host this. And there are kind of species that would still thrive in this, considering its dynamic activity. And this zone extends all the way to where the continental shelf drought. Okay, as we go down deeper, you would also expect the light to be screened out more and more as we go deeper. From 2000 to 1000 meters below, you will have the mesopelagic zone, also known as the twilight zone. You remember this for the exam, twilight. So hindi lamang sa Hollywood, hindi lamang sa landmass. So when we have this twilight, why twilight? Because this is already a very critical zone wherein the light is barely peeping out and barely creating photosynthetic activity into that water. So here we go. This is the mesopelagic is the twilight zone. Ito po siya. And then when you go down deeper, you would see a significant decrease of the species that would thrive there because there's no light and it's going to be totally dark, completely dark. This would be around 1000 to 4000 meters. And what kinds of species thrive there? Species that glow in the dark, bioluminescent organisms. Some of the strangest animal creatures that live in there. And why would they have this strange feature? Well, nature has endowed them with the gift to create their own way of navigating. They may not be able to see, sabi dito. If they glow in the dark, what does that mean? Let's have an example of the giant squid that would reside in here. So nag-glow ba yung squid? I am not sure, but you would see some kinds of fishes that would be glowing in the dark. That's how they can navigate through, because others would not totally need the light. And in fact, it says here that most animals in this abyssopelagic zone located 4,000 meters down are blind and are colorless due to the lack of complete light. They might not navigate using their eyes. Hence, it comes to mind logically the reason why an octopus would need more tentacles rather than big, huge eyes and fins. So, gets na ba natin yan? Amazing, right? So, that is why we see different kinds of creatures in this amazing ocean. And as we go down below, the bottomless abyss, also known as, well, in mythical terminologies, they have used Hades as a metaphor for the idea, of course, this is pre-exploration, scientific exploration, is that they think that is the bottomless abyss. Definitely, there is a bottom. That is why we call it the ocean floor. So now we know that the term Hades is like mythical symbolism or characterization of what is known and not known before. To summarize, we therefore know that as we went through the abyss, this is also known as the aphotic zone. The areas that have been reached by the light is called the photic zone. And this is, as we said, what creates much of the diversity in the marine life. Whereas in the aphotic zone, A means the void and the photic would mean the light. And there's still what resides in the aphotic zone. Meron pa rin. Guess what? In one of the explorations, it was strangely found out that other than octopus lurking in the dark, we also have giant red crabs. Although traditionally it was believed that nothing can exist the ocean floor given the dark, except for planktons, small microscopic organisms, but with the climate change going on and with the global warming and with the diversity of marine life we have and much of the fact that 10%, sabi nga natin kanina, 10% lang yung nadi-discover natin, hindi natin alam what really lurks in the dark. Much of it still remains a mystery. All we know is that it seems to be quiet down there and probably nobody lurks in the dark. But hey, we can never tell. Much of the exploration still about to be broadcasted or be known to the world. Last part of the module, we will be looking at human impacts on the ocean. Specifically, we will be targeting two major concerns, pollution and overfishing. First, let's talk about pollution. We have discussed this previously, and we have seen this in our small water systems like in the river. But out there is the big ocean, and how much garbage are we putting in there? 80% of the pollution in the ocean is runoff from the land. Apparently, we're not good at waste management. And it runs off into the big, huge ocean. 80% is a huge number. 80%. 90% of all floating materials. How much garbage? 80%. What garbage? Plastic, plastic, plastic. Well, at least we can see the plastic, but the most dangerous one would be those that we can't see. This would be the chemicals, chemical waste, toxic waste, radioactive. Marine debris, especially plastic, well, they kill more than not only seabirds and turtles, but so much more that we can't see. Dead zones, which are areas of oxygen deficient water where life statistics have increased drastically over. Technically, what is a dead zone? Dead zones, based on our previous discussion, would fall under the aphotic region because there's no light. It seems dead because there's no light, no life, and there's no richness in there. And it has been said that with the increased water pollution, the dead zone has expanded to a much greater length compared to the non-dead zone. In other words, you can have a dead zone that should also not specifically aphotic, supposedly photic, meaning it should teem with life, but because of pollution, life is beginning to cease. Let's take a look at other examples. Here, other interesting facts. 40% of our rivers are too polluted to fish. This is probably somewhere out there. But every year, 25%, this is US. Pollution of our fresh drinking water is a problem. If you try to browse through this internet with facts and figures of ocean pollution, I know it should come at no surprise given the fact of how much waste and how much consumerism and how much um, mediocre or poor our waste management system is. So you would find here varied kinds of plastic and bottles and human waste that are not discarded properly or recycled appropriately. So these are sad images. This is what we have done to our ocean, and so much more. Unless we stop doing this to our oceans, someday, after we have killed every single river and we upgrade to killing our ocean, then there's nothing left for us. And when you try to combine pollution with overfishing, another human activity, it's a deadly combination. So here we have just a few quantified effects of overfishing. We are plundering today's high seas. 300,000 whales, dolphins, and porpoise, turtles here. They die each year as a result of becoming entangled in a fishing gear. And 85% of the world's fisheries are fully exploited, overexploited, depleted. And if you're thinking of the big fishes out there, we can think of the countries that have the technology to go into the deep waters and have these. With the use of technology, people are catching more than what the ocean can produce. And of course, we don't need to mention the countries that are superstars when it comes to overfishing. But these are the countries that have the technology to go and detect by yung iba nga, ginagamit nila yung parang sonar technology para ma-detect nila yung mga big fishes, yung mga fins under the ocean. So these numbers are, they may be um, not updated, but if you try to go into other statistics, you would know that we are getting more than what the ocean could barely catch up. The ocean could barely breathe. And these are being, saan ito napupunta? Syempre sa bituka ng mga tao na may pera na kayang bumili with the population expansion, with the population boom. And with technology, we are actually plundering, looting in the least sustainable manner what actually doesn't belong to us, what belongs to nature. There are some marine resource sustainable practices that may exist in some tribal areas, but not among industrial areas. I watched this CNN documentary wherein I think this is somewhere in Indonesia or Malaysia. They are harvesting sea cucumbers, and they only harvest during a particular month, so that they give time for these sea cucumbers to replenish, and they will have another harvest for the next year. But for big industrial societies, they don't seem to have that mentality. Consumerism is the name of the game. Competition. Wicked tuna. Ganyan, no? 9 out of 10 large predatory fishes such as tuna, marlin, and swordfish are nearly gone. And this is a sad, sad fact. And last one, we have the effects of overfishing here. All the D's that you can think of: decline in species population, disrupting in food chains, decrease in business and trade, decrease in job and money, disruption in natural ocean ecosystems. This is definitely way more important than the decline in jobs and money. and all other economic considerations and depletion of food resources for human. In the long run, if we would try to put one common denominator for all this effect, that would be the lack of sustainability. If we fish too much now, then we have nothing left to fish for tomorrow. Just come to think of this. One day, this guy may no longer be around. Coral reefs will no longer be around. The ocean floor will end up dry. So, we'll just give ourselves a minute to enjoy the beauty of what we have before we kill them. Now, our children and great grandchildren, we have nothing to snorkel with, nothing to draw what a turtle looks like. Some days this might be called the fishes of